everyone. In this session, we will introduce the data pipeline feature of FindDataLink. If your database has a large amount of data or has a well-structured schema, and you require high data timeliness, you can utilize our data pipeline feature. It works by monitoring changes in the database logs of the source end and using Kafka as an intermediary to temporarily store the incremental parts of the source database. This ensures real-time data writing to the target end. We can perform real-time full and incremental synchronization for single tables, multiple tables, and entire databases from the data source. We will explain this through 4 aspects: data sources, synchronization scenarios, task configuration, and task operations. First, let's talk about real-time data source synchronization. It supports multiple data sources, allowing you to form synchronization links between various source and target ends. For synchronization scenarios, we support real-time full and incremental synchronization for single tables, multiple tables, and entire databases. The synchronization type can be full plus incremental synchronization, which means completing synchronization for all existing data first, followed by continuous synchronization of newly changed data. Alternatively, you can use incremental sync only, where the task only includes the incremental stage. During the initial run, it can perform real-time synchronization of incremental data based on the configured start time. Next, we have task configuration. Real-time synchronization tasks do not require coding. They can be achieved through a simple task configuration interface, enabling real-time data synchronization for single tables or entire databases. We configure the data destination, adjust the field mappings for the tables, and set some task controls for the pipeline. The visual interface makes it even more convenient for us to use. Following that is task operations and maintenance. We can monitor and manage individual synchronization tasks as well as control and manage tasks in batches. We support viewing the running status of pipeline tasks, handling dirty data, and performing batch operations such as starting and pausing tasks. Next, we will go through the steps required for developing the first pipeline task. First, we need to prepare the environment. The first step is to deploy Kafka. Since FindDataLink supports using Kafka as an intermediary for real-time synchronization, to temporarily store data from the source database and facilitate writing data to the target database, you need to deploy Kafka on your server. Next, we need to configure the transmission queue. Use Kafka as the intermediary for the data pipeline, establishing a connection between FindDataLink and database. The third step is to prepare the database environment. FindDataLink supports real-time synchronization for data sources such as MySQL, SQL Server, and Oracle, since it writes data by monitoring changes in the source database's logs. You need to enable logging on the source database. Once our environment is configured, we can proceed with the interface-based configuration operations. The first step is configuring the data source. You need to create a new data connection, linking the source and target databases with FindDataLink. Then, select the data source, the type of database, and the tables that need real-time synchronization. The third step is to select the destination. Set the target database where data will be written and specify the writing method. For instance, you can configure whether to synchronize changes in the original table's structure, such as DDL, or add a timestamp during synchronization. The fourth step is setting field mappings. Configure the target table names and the field mapping methods. The fifth step involves controlling the pipeline. Set up the handling of dirty data, preset result notifications, and other controls to manage the running tasks. Finally, there's task operations and maintenance. In the task interface, you can manage activities, view task running status, running time, and handle dirty data. Next, let's walk through setting up the first pipeline task with a practical example. Once we're in the FindDataLink data integration platform, We'll navigate to System Management. Data Connection. Data Connection Management. First, we'll establish connections between FindDataLink and both the source and target databases. For instance, we'll create a new MySQL data connection for the source. Enter the database name, host, port, username, password, and other necessary details. After testing the connection, save it. Then, we'll set up a MySQL data connection for the target database. Similarly, configure the data connection name and relevant settings, test the connection, and save it. Once the connections are set up, we can proceed to configure the task in the data pipeline. Since our goal is to quickly grasp pipeline tasks, we'll defer detailed environment setup instructions for later. Let's focus directly on configuring a task to understand data pipeline efficiently. To create a new pipeline task in the Pipeline Task interface. First, we'll select the recently configured FDR demo test data connection as data source. Then, for read mode in MySQL, we'll choose binlog log reading. For synchronization type, we'll opt for full plus incremental synchronization. This means initially syncing all existing data and subsequently syncing newly added changes. Next, select the specific data tables we want to synchronize from the database. For instance, let's synchronize the exam table by moving it to our list of tables to sync. You can sync multiple tables or even entire databases this way. Here we will use a table as an example. Then select Next to set the data destination. For the target endpoint, choose the newly created data connection. Then select the database to be synchronized. Now we have some settings. For example, whether the source end performs physical deletion or deletes the logic of target end execution. Whether to synchronize source table structure changes. Or whether to mark timestamps when syncing. Here, we will not select target end performs physical deletion. Then set the field mapping for the table. For the target table settings, you can either auto-create a table in the target database or choose an existing table. Here, we will automatically create a new table for exam. Then you can adjust the table field mapping. For example, you can delete this mapping or restore it. Then add some remarks, etc. It is important to note that we need to set a primary key to ensure the uniqueness of the data being written. This also enables the target data to have an index and improve performance. Here, we will choose the ID as the primary key for the target table. Then select Next to proceed to pipeline control. You can set the dirty data threshold, which means the task will automatically stop when the threshold is reached. Enable retry after failure to allow the task to be rerun after a failure. Set up a result notification, for example, notifying the platform's admin user if the task fails. Choose the notification channel as platform user. Modify the task name, click Save and Start. And it will automatically enter the single task management interface. Here you can see the task's running status, which is currently running. It has read 3 records and output them all. You can click on Dirty Data to check if any dirty data occurred during the task execution. You can also select the data table to resynchronize. So we can find the data table that has been synchronized in the target database. Since we set up real-time synchronization with Pipeline, changes in the source data will be synchronized in real time to the target. For example, here we add a new record with ID 4 to the data table in the source, delete the record with ID 2. And then change the score of the record with ID 3 to 88. At this point, these changes will be synchronized to the target. Next, let's check the target's status. Refresh the data table, and you will see that the record with ID 2 in the target data table has been deleted. The score of the record with ID 3 has changed to 88. And a new record with ID 4 has been added. You can also see in the historical records of management activities that the total read amount has logged the newly added rows.